class 10 o'clock, right?
Yes, sir. I have another class in 10.
Yeah, so 1.48 is correct. You give it tick over there, okay? Hello?
Sir, will I like ticket?
Yeah, tick, tick. It is correct. Huh?
Okay,
Yeah.
okay, sir.
Then next one is the B, part B. Okay, so part B,
Yes, sir.
you are asked to B1, right? Complete the column headings in table 3.1.
Yes, sir. So I give voltage, current, and resistance.
You gave voltage, current, and resistance. So they are asking you to give the column headings. That means the quantity is already labeled. Hmm.
Yes, sir.
Quantity is already labeled, so you have to write the unit in the space. So what is the way to write the column headings? You have to
Oh,
give the unit, you have to give the quantity symbol and the unit symbol, okay?
sir, it is like always while doing this kind of like table, we will give the
Yeah,
quantity and the units.
yes, yes. Quantity first, then slash the unit. Got it?
Okay, sir. Yes, sir. Then, sir, it will be voltage, ampere, and ohms.
It is voltage means give here volt. Huh? Voltage is also
Yes, sir. Both.
quantity. Voltage is also
Yes, sir.
quantity.
Yes.
Voltage, voltage, potential difference. These are quantity. Okay. I, the unit is ampere, right? Current, the unit is ampere, and R, resistance, the unit is ohm, right?
Yes, sir.
Okay. Now calculate the resistance R of each combination of resistors. Record the values of R in table 3.1. Yeah. Amjid, Amjid and Abir.
Yes, sir.
Yes, please check the discussions going on. You labeled here, what you labeled here?
Volts V,
Volt, then
ampere A,
ampere A, then
resistance ohm.
ohm. You can give symbol or you can write ohm, right? OHM. Now, Abir, Abir,
Yes, sir.
how are you?
Yes, sir. Fine.
Yeah, so little bit late, right, today?
Yes, sir.
Try to be on time. Voltmeter reading, what you got? Voltmeter reading, Abir and Tamjid.
1.48 volts.
Yeah, Tamjid also, right?
I got 1.48.
Yeah, 1.48. Both of you got 1.48, and Ifaz also got 1.48. So Ifaz, this part is done, right? B,
Yes, sir.
record the values of R in table 3.1. So what you got the value of R? You have to record them in table. You see, 3.1, we have the R here, so you should record them, right? Isn't it?
Yes, sir.
Look here, circuit 1, circuit 2, circuit 3, right? circuit 1, circuit 2 and circuit 3, right? These three circuits we have, and because of these three circuits we have voltmeter reading and current reading. Voltmeter, this one you have to write 1.48, right? This is space. Are you seeing?
Y-
Yeah,
Yes.
the space here you should write 1.48, the value you got there. Okay, then you calculate all the R. Record the values of R in table 3.1. Have you calculated? Uh, have you calculated? Amjad, Abir,
জি স্যার হ্যাঁ ক্যালকুলেট
Faz.
করছি
So what you got?
Yes, sir.
Can you tell me the values?
11.38
Mm-hmm.
5.84
Yes,
and 2.52
very good. So Abir and Ifaz, you also got that.
Yes, sir. I got the
Yes,
same one.
sir.
You calculated, right?
Yes, sir.
Okay, very good. Now,
Yes, sir.
Abir, can you please read this part? See.
Theory suggests that for identical resistors, the resistance of the third resistor combination in circuit 1 is double the resistance of the resistor combination in circuit 2. State whether your results support this theory. Within the limits of experimental accuracy, give a reason for your answer.
So what is your answer? Abir, what is your answer, Abir?
Sir, I wrote yes because the answers do not have much difference.
Okay, very good. Your answer is correct. Then first, what you wrote here?
Uh, I wrote yes as 5.84 is a month. Sir, reasonটা পারি নাই স্যার ঠিক মতো।
Okay, okay, very good. So you did the first part, yes, but the reason you did not write. Then Amjad, what you wrote?
Sir, I wrote that the results are close to each other.
What? The results?
That are close to each other.
Close to each other. Yes, because the results are close to each other. Look, in the circuit, we are saying about circuit 1 and 2, right? So in circuit 1, you got, what is the value you got? Because
11.38.
11.38. Then in second circuit,
5.84.
so if you double 5.84, what it comes?
It becomes 11.38.
So it comes 11.38. That means yes, the values are close, right? Or they are matching.
Yes,
They
sir.
are coming same. This way you can write. Is it clear?
Yes, sir.
So write it. Then next, you can write yes. It is exactly double of 5.84 volt, 11.38 you got, right? That's why it's matching. Yes, theory and practical are matching. Then part D. Tamjid, you read part D. Tamjid, hello
জি
Tamjid.
স্যার হ্যাঁ
Part
স্যার
D,
হ্যাঁ
please.
হ্যাঁ স্যার আমি লিখছি রিপিট দ্য এক্সপেরিমেন্ট
repeat experiment. So you wrote repeat experiment. Then what about Abir? What you wrote, Abir?
Sir, I wrote that we should repeat the experiment by multiple people and then average the result.
Okay, so they are saying precautions, right? Precautions. One thing is like after experiment, you are getting the repeat experiment, then you are getting the average. That is one thing. But precaution means you are taking some necessary measures so that your experimental results are coming better. So it's about some activity you are doing during the experiment or before the experiment so that your results are not hampered by the surrounding any effect. So one thing we know, if temperature increases in the conductor, then resistance also increases, right? Isn't it? Hello?
Yes, sir.
So if resistance increases, that means your current flow will decrease. So if you uh, keep your circuit connected for a long time during the taking readings, that what will happen? Your conductors will become hot. The wires you are using, those will become hot, and you will not get accurate reading. As the temperature is more in the conductor, the resistance will increase, the current will be less. So here we are getting error. What can we do for this? During taking reading, we are using crocodile clips. So what can we do? While taking reading, we are connecting the circuit, and while we are not taking reading, that time we will disconnect the circuit. Is it clear? Hello? Hello?
Yes, sir.
Like,
Sir, can you repeat it again?
yeah, I am repeating. Look, while we are taking readings, we are taking three readings, right? Circuit 1, circuit 2, circuit 3, right? So while you are taking reading, if you are keeping always connected with the circuit, then what will happen? The conductors will become hot, right? Because of the flow of electrons, isn't it?
Yes, sir.
So if your conductor is becoming hot, then resistance of the conductor will increase. It's a property of conductor, right? We know that Ohm's law, we should keep the temperature constant, isn't it?
Yes, sir.
So if you don't keep your temperature constant, then what will happen? Your resistance in the conductor will increase and current reading will be less. Less means from the required value or the standard value it will be less, isn't it? Hello.
Yes, sir.
So to avoid this error or to minimize these problems, what should we do? We should uh, keep the circuit disconnected while we are not taking readings. Okay, is it clear? Or we can say switch off the circuit between taking readings. Is it clear, everyone? Hello?
Yes,
Yes,
sir.
sir.
So write it. Write this precaution, everyone. You keep your one, don't remove it, and beside that one, you write this one. So what you are writing? Hello?
জি স্যার শুনতেছি।
Mhm.
Switch off the circuit while taking the readings.
Between taking readings, right? Yeah, while
Yes, sir.
taking readings or between the readings, between taking readings. Like you are taking readings, then you are writing or recording the things on your record book, right? Isn't it? That time you keep the circuit off. Is it clear?
Yes, sir.
Or you are calculating or you are doing some other work, that time you keep the circuit off. When you are just taking the reading, that time you keep it on. So keep the switch off between the readings, okay? Now D is done, right? Hello, Abir? Abir, you
Yes,
understood it,
sir.
Abir?
Yes, sir.
So what you wrote here, D?
Sir, we should have the circuit switched off when taking the reading.
Yes, taking the readings. Now, question number 4. Yes, question number 4, A. What is the temperature you got, all of you?
86 degree Celsius.
86 degrees.
86 degrees.
Degrees.
Amjad, you got also 86?
Yes sir.
Okay, very good. So all of you got the same answer. Then we have to record this 86-degree here in this table and get the answer. Next one. Okay, so Ifaz, you read here. State.
State which thermometer cooled more quickly at the start of the investigation. Justify your answer by referring to readings in table 4.1 on page 9.
Yes, so we are talking about this table, and from this table, you have to give reasons, logic. Uh, uh, which one you are choosing, P or Q? Which one is which thermometer cooled more quickly? So, what is your answer? Because
I wrote Q because as the rate of decrease of the reading is faster than P.
you gave Q.
Yes, sir.
Instead, which thermometer cooled more quickly? So, in you got here 86, right?
Yes, sir.
So 86 to 52. What is the difference temperature? In temperature,
34.
34. Okay, then what is the temperature difference here? 89 minus 77,
12.
12. So here in 30 seconds, the temperature uh, fell down or dropped down 34, and here only 12. So which one is losing
Yes,
more
sir.
temperature, P or Q?
Q.
Q is losing more or P is losing more? You see here in 30 seconds, the difference you got 34, right?
Yes, sir.
So if the temperature is dropping 34 degree, that means this one is cooling down or this one cooling down more. P or Q? Check. Cooling means what? Temperature will be lowered, right?
Loses.
Yeah,
Yes, sir.
yeah, loses
Loses
the
the temperature.
temperature. So, are you still in Q or you will change your mind?
It's a Q, I guess.
Still you are Q.
Yes, sir.
So why you are taking Q?
Because the decrease
Because
is more.
here decreases more. You said 89
The
minus
temperature.
77. How much? 12.
12, yes.
And here 86 minus 52, 34.
34.
So temperature drop is more where? P or Q? Temperature is falling down more where? In P or Q?
It's P. Oh,
P. It's in
yeah,
P.
I get it.
So how can you take Q? Look, after 20 seconds, you see, everywhere you take. After 60 seconds, then after 90 seconds, if you compare at least 3, 4, so what you are seeing here, what you are observing here,
The temperature drop.
hmm, yeah, the temperature drops more where? In P, right?
Yes, sir.
So what will say? Which one will cool down more quickly? P or Q?
P.
P. So you change your answer, right?
Yes, sir.
You should correct it. Then what about Abir and Tamjid?
Sir, I wrote
Yes,
P
I'm.
because the temperature decreases in less time.
Yeah, Tamjid, you?
Sir, I wrote that P because it has a larger temperature drop.
Yeah, it has a larger temperature drop. Uh, what can you compare? Like it has larger temperature drop with the same time, right? You should mention the time.
Okay, sir.
Okay,
Hmm.
you should mention the time that how you are comparing it.
Hmm.
Your answer should be P, and because there is larger temperature drop in the same time. Then now, if you are done with this one, we can go to C, right? Yeah, Abir, can you please read C?
Suggests two conditions that must be kept the same to ensure that a fair comparison is made between the rates of cooling of the two thermostats. Same room temperature and start at same time.
Again, say same room
Same
temperature.
room
I understood. The second one, what you said?
and start at same time. Start
Starting
together.
same time. Okay, starting in the same time. Very good. Then, what you wrote, Amjid?
Sir, I wrote that same room temperature and same temperature of the water.
Same
Yeah,
temperature
the
of the
water.
water. You can say another thing, more specific. That will be a more specific. Like if you say same initial temperature, right?
Yes, sir.
Same initial temperature. So what about IFAS? What you wrote about condition 1 and 2?
Sir, I didn't do it.
Okay, you didn't do it. Okay, uh, very good that you tried. At least you tried, and you are saying that you couldn't do it. Thank you so much. So already you got the idea from them, right? Now we
Yes.
can explain it why we are keeping the room temperature constant. Uh, if the room temperature is not constant, our experiment will not be fair, right? isn't it? Because
Yes, sir.
it depends on the room temperature, how faster the energy will be lost in the surroundings. If the temperature difference is more, then there will be faster temperature loss. If the room temperature and our water temperature is close, uh, like our room temperature is 30 degrees, then water temperature we are taking that one. uh, that one is uh, 80 degree or 90 degree. Then the gap between our room temperature and our the water temperature is around 60 degree, right? So
Sir,
that time the loss or the rate of heat loss we will get, if your room temperature is, for example, you are using AC, then your room temperature is 20 degree or less than 20 degree, then your temperature loss or heat loss will be faster, right? Isn't it? Hello.
Yes, sir.
So for this reason we should use our room temperature constant. Then Abir, you wanted to say anything?
yes,
Abir?
sir.
Yeah,
Sir, won't we do question number one?
we will do. I did not finish it. I did not say you that this is over, did I?
Okay, sir. Okay, sir.
Okay. Condition two, we said there should be same initial temperature of water, right? If you are having same initial temperature in both the cases, then it will be a fair experiment, right? Isn't it? Then you can compare their readings, how they are dropping the temperatures, isn't it? Because, hello,
Yes, sir.
so they
Yes.
should have same initial temperature. Now, for these two questions, I am sending you the mark scheme. Okay, now then you can take your answer, verify answer later on. Okay, uh, because after finishing this class, you can have some time to observe and assess your answer. And if you think there is something more to add from here, you can add on your paper. Okay, in your worksheet, lab worksheet. Clear, all of you? Have you got it, everyone?
Yes, sir.
Okay, I
Yes,
just
sir.
gave you the mark scheme of these two questions, 3 and 4. Now we are going to question number 1. That one Abhi was saying, because we did question number 2, we did question number 3, we did question number 4. Question number 1 is left because I told you that in my presence you will do it. Okay. The light one, in my presence we will do it because the theory part of light we did not revise in our theory classes. That's why I don't know whether you have all the knowledge about this question to solve. So please go through. Amjit, please read.
A student investigates the refraction of light by a glass block. Um, she places the glass block on a sheet of paper and draws around the outline of the block. She uses a ray box to shine an incident ray onto the side AB as shown in figure 1.1. The ray is incident at point E.
Okay. Then next.
On figure 1.1, draw the normal at point E.
So what you have to do with your pencil and your ruler, you have to draw
Straight
one
vertical line.
vertical line that is perpendicular. Will be perpendicular with AB, right? 90 degree with this surface. So draw it. All of you draw it. quickly. Are you done with drawing? This way you draw one line, huh? This way, and it should cross, huh? Cross.
Sir, is dotted line fine?
Yeah, dotted line is awesome because it is imaginary line, right?
Yes,
So
sir.
this way you draw one normal, and after drawing you have to use your protector. Do you have the protector with you now? First,
Yes, sir.
yeah, use the protector. They are saying measure and record the angle of incidence I. So angle of incidence, you know what is angle of incidence? If your normal is here, then from normal till to the incident ray, it is your angle of incidence. Sometimes the students are doing mistake that they are taking, sometimes it happens that they are taking this angle. Huh? So you be careful about this. Always you measure the angle from the normal. Okay, from normal it will start, then go to the incident ray. So tell me what is the value of your angle quickly.
40 degree.
40 degree. Then what about Abir and Jit?
Yes, sir, 40 degree.
40 degree.
Yes, sir, 40 degree.
40 degree. You also got 40 degree. Very good. Very good. So we are done with this part. Now we are going to next. Yeah, read. Amjad, read.
Uh, the ray is refracted into the block at an angle of refraction 25. On figure 1.1, draw the refracted ray. Continue the ray until it reaches the side, meets the side CD of the block. Label the point where the refracted ray meets the side CD with the letter F. Okay, sir,
Yes.
go on.
So here you will do part B. From here you should get from this normal always get 25 degree with your protector, and there will draw the refracted ray. Refracted ray will continue till CD, where refracted ray intersects CD, there you will label F. Is it clear? Hello?
Yes, sir, clear.
Okay,
Yes.
so do it, complete it. Part B you finish, then after that, the last part, C. First, you read. C.
Describe how the student accurately traces the path of the light emerging from the block through side CD.
For this one, I am giving you the mark scheme. Take it from the mark scheme, and we will discuss it from the mark scheme now. Check. Second group. Huh? Have you got it? Question number one is there. I sent both.
जी sir,
Question number
page.
one is also there.
Yes, sir.
At the bottom, you see, we will prefer the first one. What is written there? That is, place pins on emergent ray. The light ray which is coming out from CD, that is called emergent ray. Student should place the pins, optical pins, uh, on the emergent ray with some gaps, right? One after another. Then second mark is for drawing lines. The student will remove the pins later on and join the lines, yeah, with ruler, and that is giving you the emergent ray. Is it clear? Hello?
Yes, sir.
So what you'll write, place pins uh, on emergent ray, uh, place optical pins on emergent ray, and then second point is draw a line joining the marks, that is pinholes. They are saying pinholes, that means the marks from the pin back to back, yeah?
Sir,
This way.
for 2 marks, we have to give 2 ways, like
You
two
have to
answers.
write 2 points. 2 points. Like
Oh,
one thing is you will identify the path. Then second mark is for drawing line on that identified path.
okay, sir.
Okay, is it clear? Okay, so this is done, right? Our this paper is done. Now, if us about you, question number
Yes,
two, we
sir.
will do later. Okay, when we'll get
Okay, sir.
some time, that time we will do this makeup, inshallah, later on. Now we will go to our next one, that is set 3. Okay, before going to set 3, we will have a break for uh, 5 to 6 minutes. Okay, because this recording requires some minutes to processed. Okay, otherwise next recording will not be done. Thank you. Huh? Join at 9:48. Okay, everyone.